Years ago, all this trash would go to a landfill and stay there forever. But today, engineers have found a way to harness its energy and turn it into electricity. I'm Noelle, and today we're going to follow this trash around to see how it can turn on your computer, your TV, and your lights. These long days can stink. One person's trash is another person's electricity. Joe Becker, the facility manager here. Joe, this looks like a gigantic pile of trash.
This right here is the beginning of the process of taking your trash that you bring to the curb and turning that into electricity.
How much trash is here right now?
Right now we have approximately 5,000 tons of trash.
A school bus weighs about 10 tons. 5,000 tons of trash weighs as much as 500 school buses. That's enough school buses to take 39,000 kids on a field trip.
The average person throws away 1 ton of trash a year.
So you burn that and then make electricity.
Burn it, which means a big fire and a lot of heat, and we boil the water that's in the boiler that makes steam, and we send that steam to a turbine generator like a pinwheel. The steam hits the pinwheel, connected to the generator, and that makes electricity.
Let's see more on how this works. In the first step, chemical energy in the trash is released as heat when the trash is burned. Then, this heat energy is absorbed by the liquid water. When enough heat is absorbed, the water changes from a liquid to a gas, which takes up more space, causing it to force its way down the pipe past the turbine where there's less pressure. This spins large magnets in the generator, causing electrons to move through the wires. These wires attach to the electrical grid, which is a giant circuit that connects homes and businesses to electricity.
Everything that you throw away, it still has energy in it. The paper has energy, the plastic and all that comes from different materials that still have energy in them.
All matter contains potential energy. When molecules are rearranged to form new products in a chemical reaction, like fire, some of the energy that holds the molecules together is released in the form of kinetic energy, like heat, light, or motion.
Basically what you're saying is someone's diaper could become a source of energy.
Your brother's diaper turns on those lights.
I'm here with Joe at the top of the trash pile, and that claw is picking up a ton of trash right now. How much is in that claw?
That's amazing. There's 3 tons of trash.
How much is 3 tons?
3 tons is about as heavy as a Hummer, an Asian elephant, or 300 large turkeys.
What's it doing with that trash? Why is it just moving it over there?
What you try to do is mix it all together so we don't have a big slug of wet stuff or a big slug of dry stuff into the furnace. It helps us even out the fuel.
Wow, and that claw, basically, it almost looks like, have you ever been to like an arcade game?
And all you kids, I'm sure you're gonna be great crane operators because he's sitting there with joysticks and he's making that thing move just like people do with video games.
Do you think I can go try it out right now?
Oh yeah, let's go.
All right. Joe, this is the game room?
No, this is the crane pulpit. There's somebody in here 24 hours a day, 365 days a year, and Gene here is our expert crane operator. What his job is to go down, get the trash that is pushed in off the tipping floor, mix it all together, and then feed it into the furnace.
So what does this chair do? How do I move the crane?
Basically, this joystick here runs the grapple, makes it close and open, and then that one over there moves the crane back and forth to where the position is to be able to put it into the furnace.
All right, I'm ready to try it. It's not as easy as it looks. So we just dropped from the claw into this chamber, it looks like. What is this right now?
This is what we call the feed chute, and this is where the trash starts its journey from being trash, and we turn it into energy. About 20 feet down on the other side of this trash is where the flame is.
Is it moving? It looks like it's moving down.
Yes, it's moving. It's approximately we process about 34 tons per hour of trash. And what happens is at the bottom of this column, the trash is resting on a feeder. The feeder comes back, drops onto the table, and then pushes it out.
Into the giant flame.
Yes.
And that's what we're going to go see next, is a little bit of the
That's
flame.
where we're going to go down. We're going to look at the flame, and we're going to look at all the controls that run the combustion to make the electricity.
How hot is that fire?
The fire is approximately 2,000 to 2,200 degrees, and what the control room operator's job is to have perfect combustion. Perfect combustion helps us with a lot of things. The amount of ash, the amount of particulates that go through the boiler with the flue gases. The perfect combustion, it minimizes the amount of carbon monoxide, because you get carbon monoxide when you don't have complete combustion. Everything you see behind you is controlling what you see here. This is basically a picture of our whole system, from the boiler to the air pollution control system. Throughout the process, we're neutralizing the nitrogen oxide, the sulfur dioxide, and then the final step is the bag house, which is the bag house is on thousands of bags. They're like a vacuum cleaner bag, where the particles stay on the outside, the clean air goes through the middle of the bag and goes out the stack. Basically what happens, the steam comes down this pipe, goes through the turbine, which is connected to the generator, and basically the generator is just a bunch of magnets spinning around. It is loud.
Good thing we're wearing our earpieces! What is this? It looks like it's from a science fiction movie.
No, it's just where we take the steam that it was always in the turbine, and all the energy is gone from it. We bring it up here, and in these pipes, we take the cold air on the outside, put it through the fan, and it condenses back into water, and we reuse it in the facility.
This is also where they dry their clothes!
Coming up, what happens to the trashed material that doesn't burn, including millions of dollars in coins?
What happens if the trash contains things that don't burn? Let's find out from Mike Van Brunt, the Director of Sustainability here at Covanta.
This is where we separate out the metals after it's gone through the combustion process.
How do you separate the metals from the ash?
We use magnets that actually pull the metal out of the ash. What we found is about 2.5% to 3% of the trash that we get, we can pull out as metal.
So let's say there's 100 trash bags, about 3 of them are full of metal?
That's right. So the metal actually gets picked up by a recycler, and they'll take that metal and turn it into new products.
These are huge piles of metal. This all comes from your plant?
That's right, and this is only about 2 weeks worth of metal that we recover.
How much metal do you get each year?
We process about 500,000 tons of metal, even more than that. Now, that's the equivalent of 6 Golden Gate bridges. We get money. Annually, every year, Americans throw out about $62 million worth of coins. We can recover that and send it back to the mint for processing.
It's a great thing you guys are here to help save all this metal and recycle it.
That's right. Recycle first, but we're able to pull out quite a bit if it comes to us.
After the metals have been separated to be recycled, the last piece of solid waste that's left is called ash.
Mike, this is a pile of ash. Where did this ash come from?
So this ash comes from the material that doesn't burn in our combustion process. So picture things like a broken coffee cup or floor sweepings that you sweep up in your garage. That's the type of material that winds up in our ash. We actually have a very exciting project that we completed down in Florida where we've started using some of our ash from one of our facilities as road material. It's a great way to reuse the material that would otherwise go to waste.
At the end of this process, how much ash is left over compared to what you originally started with?
It's about 10%. So if we had, say, 10 garbage bags full of trash, we'd wind up with about a garbage bag full of ash.
That's really amazing. We're standing here at the monofill where the ash ends up. But imagine, there'd be 10 times as much trash here if it weren't for the waste to energy process. This helps the environment in many ways.
Trash rotting away in traditional landfills generates a gas called methane, which is a greenhouse gas that causes our atmosphere to trap in heat. Increasing amounts of greenhouse gases in recent years is contributing to climate change. But since the waste-to-energy process reduces trash by 90%, methane emissions are also significantly reduced.
Energy from waste is actually a solution to helping to reduce greenhouse gas emissions. And it can be part of a much bigger solution around more sustainable waste management.
So wait, you guys are burning trash, but you're actually reducing greenhouse gases?
That's right. So when we burn the trash, it emits CO2, but we actually reduce greenhouse gases by keeping waste out of landfills that would have generated methane, by putting power onto the electrical grid that displaces other fossil fuel-fired electricity, and by recovering metals, which help save the greenhouse gases that would have been emitted making those metals from raw materials. So this is where the actual emissions, after they've gone through the cleaning process, gets emitted into the atmosphere. And that stack is about 300 feet high.
But why can't we see a lot of smoke coming out of the stack? Well, it's because this burning process is much different than a fireplace or a campfire. Smoke typically comes from what is called incomplete combustion. But the combustion process here occurs at extremely high temperatures and can be monitored to achieve a cleaner, more complete combustion. Plus, the combustion gas also passes through scrubbers and filters before coming out of the stack.
We've seen trash processed into electricity. What happens to the electricity from here?
So after it leaves the turbine generator, it comes to here, which is our substation. From there, it gets distributed to residents and businesses here and elsewhere.
How many houses can you power with this electricity?
About 40,000. That's enough to power the houses in this city.
From the time trash arrives and enters the furnace and then gets turned into electricity, how long does that take?
So the process from when the crane operator puts the trash into the boiler, it takes about an hour before we turn it into electricity. And you think about it in comparison, if that trash had gone into a landfill, it could sit in that landfill and decay for 100 years or more.
I'd like to thank Joe, Mike, and Covanta for showing us how your trash can be turned into energy.